There is uh, tremendous expansion in the protein world to improve treatment quality and to make it more accessible, to have more patients and to reach to more patients, and therefore to make it more available. So there is a natural evolution in external beam therapy towards rotational therapy. In the case of conventional radiotherapy, photon radiotherapy started with 3D beam arrangements. It moved on to IMRT, and then it ended up easily falling into rapid arc and all of the technology that was developed precisely to provide rotational therapy. So it seems that proton is following the exact same track. And I wouldn't be surprised that in general, in the future, all external beam therapy, including carbon ions and so on, will follow the exact same track. The reason why, in the case of particle beams, is double. It's not single base, such in the case of the conventional radiotherapy business. In the case of the conventional radiotherapy side of things, they wanted to improve efficiency. They wanted to be able to get more patients under the beam. In the case of particle beams, which is what I've been advocating for the past pretty much 10 years, is that we can get a better response from the patient, that we can radiobiologically optimize our treatments better so that we can maximize the efficiency and the effectiveness of our treatments, reduce the overall dose at the same time that we can treat our patients faster.
Yeah, I just think that rotation therapy is the next step as we make protons more affordable, more compact, and then now you have actually many advantages: cost reduction plus we improving the quality of the treatment. We often refer to that as the conformity index, and so the ultimate goal for any physicist is to say, can we conform the dose better? And now we actually do that. Plus, we bring the cost down.
And I'm going to add one thing. So there is also an investment worldwide on other particle flavors, carbon ion being the best known, right? Carbon ions rarely, only one center in the world in Germany has a gantry, is mounted on a gantry. Everything else is going to be fixed lines. So I think Leo is extremely well positioned itself, because you will be able to rotate the patient on the chair for any kind of particle modality that you want to consider. So Leo will be providing the basis to be able to do particle, not just proton, but particle arc therapy on a routine basis with a minimal extra work to go from protons to carbon ions and so on.
Correct, yeah.
The first thing that we're gonna do is we have to start from basic building blocks. The first thing is we need to bring in a simple stage, a rotational stage that we will be able to start testing the beam line with, to extract all the information that is required from this element called the scanning controller. It's essentially the brain of the machine telling where the beam is supposed to be at any given time, and getting the information from that scanning controller in order to facilitate the delivery in arc mode. Once that is done, we need to then build a connection in between that scanning controller and Leo chair. There has to be an electronic interaction in between the two systems talking to each other. So then the Leo chair talks to the scanning controller and tells, now is your turn to give me this spot, because that's what the plan was asking for. Yeah. And then from then on, it's just a matter of increasing the efficiency of the treatment to sort of optimizing both on the planning side and the delivery side, the treatment process.
And the beauty about this specific project is that while we're working on full clinical integration and bringing the machine up to clinical speed, Alejandro can do all this work in what we call service mode. So the entire work in the next 2 years can be in a non-clinical fashion. And then what I'm looking forward to is to show arc therapy on like a human phantom while we're doing the clinical integration.